Okay, so you will know what problems you missed the most, and you might need to spend some more time on that. And I could see some of the things that trouble doing factoring, so you might need to work on that. All right, okay, let's, today we're gonna continue to look at addition. So let me share the screen with you. On Tuesday, we talked about how to multiply or divide rational expressions. The process is pretty much similar to, let's take a look here. Not this one, here. Okay, so the process is very similar to how to multiply fractions. Okay, because fraction is rational, rational is fraction. Again, fraction, usually we don't have variables in there. That's why we call them rational expression. But you can, if you want to call these fractions, and that's not a big problem. Okay, so how do we multiply them? Straight across, and you try to factor further to see if you can find any common factors and cross them out and copy whatever you have left on the top and on the bottom. Okay, so the process is pretty much similar. And we also started talking about how to add and subtract. Okay, go back there. Okay, so how to add rational expressions. Subtraction is similar. So you will found the least common denominator and equal the denominators. So change the denominators to the common denominator and then keep the denominator and the numerators. Okay. Add the numerators. So that's what we did in this example. The new thing is when you equal the denominator, you might have to distribute when you do the multiplication. So previously, when we equal the denominator, you multiply a number. So the top we have a single number. So you will just multiply 3 and 3 to get 9, 1 and 2 to get 2. But now we could have 3. You got to distribute the number you multiply. 3 times x, 3 times 2. Distribute 4 and distribute 2, especially when you have a minus, the minus sign also needs to be distributed. So negative times negative will become a positive there. Okay, and then you got to combine like terms. Well, we also started to talk about another case because in the first example we did, the denominator does not have any variables. The numerators do have variables, but the denominators do not. So we looked at these, I guess I didn't finish the second one. We look at these two examples. The denominators have variables in them. Okay. First thing, following the steps, the first step was still, again, the steps are still going to be the same. So we still need to find the least common denominator. I did give you a tip. If everybody can remember the tip, that would be great. If you somehow forgot the tip, and you can use the way we reviewed it during the first week of class, how to find the least common denominator of numbers, least common multiples. So what you do is you start with, you look at all the denominators, say n squared. You break down. When I say breakdown, I mean multiplication, not addition. So n times n equals n squared. And similarly, the second denominator, 3n, can be factored as n times 3 or 3 times n, because line up the variable n, create a new column for 3. And for the third denominator, 2, we can just keep it, because 2, you cannot break down 2, factor 2. And so you can't have 1 times 2, but the 1 doesn't do anything. So that's just write down, create a new column for 2. After that, you will bring down one number or variable from each column. So bring down n, bring down m, bring down 3, bring down 2. So you multiply all of them together. N times n gives us n squared. 3 times 2 gives us 6. So that's how we figure out the least common denominator, 6n squared, in the old way, the same way we did before, with the variables. But the quick way to do is, again, you can see this process might take you a little bit of time. So the quick way is just look at, so So you can just look at the denominator. I'm going to write down the denominators here, n squared and 3n and a 2. So first you look at the numbers. Found the least common multiple of 3 and 2. So I think most of us can see it's 6. 6, 3 goes into 6, 2 goes into 6. And look at the n squared and the variables, n squared and n. We picked that this time different from GCF. In the first exam, we talked about the factoring. GCF, you got to take the lowest. But now for LCM, you take the highest. Okay, so GCF, you would take the lowest exponent, the one with the lowest exponent, but LCM, you take the highest exponent, the one with the highest exponent. So we take n squared. So that will give you LCM immediately. Okay. Similarly, I did the long way to break down everything, break down 12, 2, 2, 3, break down a squared as a and a, break down b squared, and line up all of them and bring down the number or variable from each column. So I end up with 12a squared b squared. But if you do it with the tip, it's going to be quicker. So when I do that, I'm still going to kind of line up the numbers and the variables. So 12 and 3, well, they're both going to 12. So that tells us the least common multiple of 10 and 3 is 12 and 3 is 12. So you don't have to break all the way down. And when you look at the a squared, this one is missing an a, where if you want to put a there, it's going to be a to the 0 because we know a to the 0 is 1, right? So if you really want to put a, because zero copy of a, you can put it there and take the one with the high power, which is a squared. And compare b and b squared. B means b first, of course. The high one will be b squared. So take the highest exponent or higher. Okay, so that gives you the LCD immediately. Okay, so you can remember the tip, and that's going to save you a little bit of time. But if you forget the tip, do the slow way. Okay, so after we found the least common denominator, that's only the first step. You want to equal all the denominators. So you want to change, let's see. Okay, let me erase these. After you found the least common denominator, you want to change all the denominators, say 3n squared. And the first one is n squared to 6n squared, 3n to 6n squared, and 2 to 6n squared. Now, look, if you want to change n squared to 6n squared, you will have to multiply by 6. Okay, because 6 times n squared is 6n squared. So that's what I did here, times both top and bottom by 6. In order to get 6n squared, well, first you're going to change 3 to 6. That means I need to multiply by 2. 3 times 2 is 6. If you want to get n squared from n, you multiply by another n, because n times n gives you n squared. So that's why I multiply the second fraction by 2n, both top and the bottom. For the last one, 2 as a denominator 2, you're going to multiply by 3 and n squared, because 2 times 3 gives you 6, n squared will give you n squared. So look, the first denominator already has n squared. That's why we only multiply by a number. But we may need to multiply variables too, because if you need n squared, but you only have n in the denominator, you need to multiply another n. If you don't have n squared at all, you have to multiply by n squared. So you could multiply different things. Previously, with numbers, you always multiply another number. When we have variables, you may have to multiply a variable. Depends on what you have. Okay, so after we multiply the first one by 6, the second one by 2n, the third one by 3n squared, we end up with 6 times 5 is 30. 2 times 2n, because the second one we multiply by 2n, so you get 4n. Third one we multiply by 3n squared, that gives you 3n squared. And then we add or subtract the numerators. So that's what we ended up with. And that's the final answer, because this is cannot be reduced any further. Okay, so I just went over the process here again. Similarly, we can do the same way with the second one. So the denominators we have 12a squared b, but now we want to change this to the least common denominator, which is 12a squared b squared. And we also want to change the second denominator to 12a squared b squared. So the top one compare then. So we have 12, 12. We don't need to multiply any number. A squared, we already got a squared. We don't need to multiply by any number. We need a b squared, but we only have a b. So which means we should multiply by b. Because this b we have in the denominator, this b times another b will give us b squared. So this is what I'm going to do. Multiply both the top and the bottom by b. So that would give me 5b in the numerator. The denominator will be 12a squared b times b squared. That's exactly the least common denominator, which we want to get. Now, this for the second denominator, we have 3b squared. We didn't have this, or a0 if you want. How do we get 12? First, we multiply by 4. 3 times 4 is 12. Now, we don't have a squared at all, so let's go ahead and put a squared there. And b squared, we already have b squared, so you don't need to multiply anything. You will get that. So that's what we're going to multiply. 4a squared, 4a squared. So now look at the bottom. 3 times 4 is 12. A squared, b squared, b squared. That's exactly the least common denominator we wanted. The top numerators, 4 times 7, 28. A squared times a, it's going to be a third. Okay. Now, since we got the same denominator, the matching denominator, we can keep it and just add the numerators. And again, there's nothing we can do. This is already the simplest form. Okay, because remember, if you want to simplify any fraction, you need to find a common denominator to simplify. And apparently the top doesn't have any common denominator. The same thing here. If you look at the top, no common denominator. And this looks like a trinomial. But even if you can factor this trinomial, we know when after you factor trinomial, it looks like something plus something or minus something. It looks like this. And the bottom does not have any common factor. Any factor looks like this. So that's why you didn't even have to try to factor this. And the only thing that can go into the bottom would be 2 or 3 or n, right? But the top, look, 2 doesn't go into 3, and 3 doesn't go into 4, n doesn't go into 30. That's why this is already simplified. The same thing here. The only thing that can go into the bottom will be a 2 or 3 or a or b. Well, this one doesn't have a. 2 doesn't go in here. 3 doesn't go in there either. And this one doesn't have b. So that's why we cannot reduce this any further. Okay. Most of the time, well, I wouldn't say most of the time. So the problems I'm going to give you, probably you don't need to, should be already simplified after you add them. But occasionally you might have, for a little high level, you may have to still, after you add them, you may still need to reduce like we did before. Oops, what happened? Well, I don't know. I just got rid of everything that I just wrote. Okay, so what we did before, simplifying, you might have to factor each one and cancel common factors. But for these cases, for addition, subtraction, the problems I'm going to give you should be already simplified. Okay, so let me quickly put this solution back here. So I will post this on Blackboard. Times b, so you get a 5b plus times 4b, 4a squared, so you get 28, a third. Okay, so you get 12a squared, b squared, and with 5b plus 28a cubed. That's the final answer. Okay, any questions? Okay, so now I'm going to look at the other type. It's still addition and subtraction, but in the denominators, you may have a plus or minus in there. Previously, we did not have any plus or minus. It's 3n squared, 6, you have n squared, that's all multiplication. You have 3n, that's multiplication. 2, of course, does not have plus in there. And the same here, 12a squared b, it's all multiplication. It's all multiplication, all multiplication. So what if we have a plus in the denominator, a plus 2, or x minus 3, or 2x minus 1? Now, the idea is still the same as before. Okay, a plus 2 cannot be factored any further. A, of course, we cannot. We can still use the way we learned before, how to factor, how to find the LCM or LCD. So what we said before, so we can break down each denominator. So let's break down A. We can't, because A would just be A. You cannot break A squared. You can break down as A times A, but A you cannot break down at all. Okay, just like 3, you cannot factor 3 as anything. Okay, so next we are going to break down A plus 2. Let's see. And A plus 2. Again, be careful. Don't think of it as A and 2. It's addition. When we say factor, it has to be multiplication. So if I give you A times 2, yes, you can factor it as A times 2. But here it's plus, so it's not equal to, this is not equal to A times 2. So A plus 2 is not factorable. You cannot factor it any further. No GCF. If you look for what they have in common, A and 2, nothing has A, the other has 2. They have nothing in common. Secondly, if you try to do other types, say, besides GCF, we have difference 2 squares. It's not even difference, and we don't have any squares. It's definitely not trinomial, because trinomial has 3 terms. It's not grouping either. We don't have 4 terms. So A plus 2, you cannot break down any further. So A plus 2, you can treat it as A plus 2. Think of A plus 2 like 3. If I want you to break down 3, you just have to say, well, that's just going to be 3. The same thing, A plus 2 cannot be factored any further, cannot be broken down any further as something times something. So you would just have to write it by itself. A plus 2 and A, they're different. So we're going to create a new column for that. So MCM, remember we bring down 1 from each column. So I bring down A from the first column, A plus 2 from the second column. So that will be our least common denominator. Now you don't really need to multiply them with the variables, just keep it as it is. I mean, yes, you can distribute A to both of them, but let's just keep it as it is because it's easier for us to figure out what we need to multiply. So we found the least common multiple, which is just multiplying them. Okay, so let's see. The first denominator A, how do I change it to our least common denominator, which is A times A plus 2? Now, by looking at that, we can see we just have to multiply by another A plus 2. So we're going to multiply both top and bottom. Let me just rewrite it. It's a little difficult to see, probably. I'm going to copy this down, A minus 3 over A. Save a little space here. And I am going to, now I'm going to do the second step to equal the denominators. So I realize in order to get the LCD, I need to multiply by A plus 2, A plus 2. For the top, make sure you put parentheses for that because A plus 2 needs to multiply with the entire top, which means both of them. Now, similarly, for the second denominator, which is A plus 2, we want to change it to the common denominator A times A plus 2. Well, it looks like we already have that. We just need to times it by A. So let's take the second fraction, multiply both the top and the bottom by A. Okay, so now let's look at the common denominator. A times A plus 2, A plus 2 times A. That's the same thing by the commutative property. And the top, we just need to work them out. So this is, I'm going to copy it one more time and maybe do the operation in the next step. You could go ahead and just do FOIL and work it out this way. So we're going to have A times A squared, A times 2, 2A, and negative 3 times A, negative 3A, negative 3 times 2, negative 6, and plus 4A. The bottom, you can leave it as it is. Okay. The denominator, you can just leave it. Usually we like you to work out the numerators and the denominators. If you want to multiply them out, you can also leave it as it is. Okay, so now we're going to simplify the top. The reason we want you to leave it as it is because maybe you will be able to simplify it further. I mean, reduce a top factor from the bottom. Say you have a in the bottom, maybe you have a on the top, you can cross out. So let's combine like terms. 2 minus a plus 4, so that's going to be plus 3a minus 6. Okay. And that part right here, the top is a trinomial. And this trinomial is not factorable. If it is factorable, so maybe it is possible that you are able to factor the top as something times something, and you found the a plus 2 in the numerator, that a plus 2 can cancel a plus 2 in the bottom. But in this case, you can take a quick try, and this is not going to factor. So if you cannot factor that, and you won't be able to reduce this any further. So that would be the final answer. Okay. Any questions about this example? As you can see, the process is still the same as before. Finding the LCD using that process. Secondly, equal the denominator. Multiply whatever you need to get the denominator to match. After that, you multiply out, but you may have to use FOIL or distribution and combine like terms to get them. Okay, the next one would be very similar to that. And so look for the LCD. Probably you already kind of, you can get the idea of, from the first example, a is not breakable, is not factorable. A plus 2 is not factorable. If but neither of them is factorable, the LCD would just be the product of them. The same way, x minus 3 is not factorable, similar to a plus 2. 2x minus 1 is not factorable either. And so the least common denominator is going to be x minus 2 times 2x minus 1. So the LCD is going to be x minus 3 times 2x minus 1. Okay, if you have trouble seeing it, you can still do the same way down here. So you want to break down x minus 3, which we can't. So x minus 3 is going to be itself. And 2x minus 1, we cannot break down it any further either. So you will just bring down, create a new column for that. So 2x minus 1 is considered as a factor of itself, because of course 2x minus 1 goes into 2x minus 1. Then you bring down 1 from each column, from first column, second column. You're just going to multiply them, and that's the least common denominator. Okay, so if neither of the denominators is factorable, the least common denominator is going to be, the tip is just going to be the product. Just multiply them. Okay. All right, so let's go ahead and see how we get. So the first denominator is this. Let me copy this down here and copy it one more time. 2x minus 1. So we are going to change the first denominator, x minus 3, to that least common denominator. So as you can see, we're missing that. So that's why we're going to multiply 2x minus 1 and 2x minus 1. Now, the second denominator, we already have 2x minus 1. We have 2x minus 1 already. We just need to multiply by the other one. So I'm going to multiply both top and bottom by x minus 3. After this process, you can see we end up with the common denominator, which is x minus 3 times 2x minus 1. See the same thing. The top, which is, let's just go ahead and distribute right here. So distribute and distribute. 2 times 2x, 4x. 2 times negative 1, negative 2. Now, the next part, be very careful. When we distribute it, the next part, make sure you associate this minus with 4. So you're going to distribute a negative 4 to whatever inside. So it's negative 4 times x. Because the reason is this minus sign goes in front of the fraction. So the minus sign, you need to use it either for the top or the bottom. Usually we don't use it for the bottom. Look, I didn't change the bottom. So this minus sign, I didn't use it for the bottom. So I have to use it for the top. Okay. Let me finish this and it kind of explain a little bit more. So negative 4 times x, it's negative 4x. And negative 4 times negative 3, that gives me a positive 12. So here, this plus sign right here is got to be very careful because some students might think this minus sign, I just copy it. I'm distributing 4x minus 12, 4 times negative 3. But actually, this minus sign is used for the entire top. So you got to distribute negative 4. After we simplify this, 4x cancels 4x, negative 2 plus 12, that's a 10 in the numerator. Denominator, I'm just going to keep it as it is. And notice that there's nothing, can be no common factors from the top and bottom. So that would be the final answer. A little quick explanation, why can I use this minus sign for the top? Okay, so if you think about division, when you have a negative, let's say 10 divided by 2, this minus sign can be put in front of the whole division, or you can move the minus sign to the top to change the question to negative 10 divided by 2, or you can move the minus sign just to the bottom to change the question to 10 divided by negative 2. Although the sign is in different positions, the answer is going to be the same. See, you do 10 divided by 2 is 5, negative 5. A negative divided by positive, you still get a negative 5 there. And positive divided by negative, you still get a negative 5 there. So you will end up with the same answer. But one thing we need to be careful is you cannot distribute the negative sign to both of them. It doesn't work that way. Okay, there's no rule, no such rule. You can distribute the sign if you have, but fraction is not like parentheses. So you cannot use the minus sign for both top and bottom. But you can move it to either the top or the bottom. So normally the tip is usually in algebra, we like to move the minus sign, move the minus sign to the top. If you have minus sign in front of fraction, you move it to the top. We want to keep the bottom sort of like a positive without extra minus sign in front of it. Okay. All right. So questions? The last example for this section will be negative 3 minus 4 over 3x minus 5. So we are going to change, just like when we did the problems before. If I ask you to do 3 plus 7 over 5, you could put a 1 underneath 3 to change them to both to fractions, and you can find the least common denominator to do that way. So that's what we're going to do. Put a 1 underneath, and now look for the LCD. Well, 1, anything goes into 1. So when you look for LCD, it's just going to be the other, because 3x minus 5 is not factorable, and so the LCD, well, just like 1, you cannot break down 1, it's just going to be 1. And 3x minus 5, it's just going to be 3x minus 5. Cannot be factored any further. So no GCF, not difference to square, not trinomial, not grouping. So after you multiply, then it's just going to, 1 doesn't change that, right? So that's your LCD there. The LCD would just be the same as 3x minus 5. So now I'm going to change the first denominator 1 to 3x minus 5. Now how do we change 1 to 3x minus 5? Just multiply by 3x minus 5, because 1 times anything times 1 will be itself. So let's work out the first part, which is negative 3 over 1. And I'm going to just copy that second part. So I just copy the problem one more time and use a different color to show what I'm going to multiply. So I'm going to multiply by 3x minus 5, both top and bottom. And for the second part, you multiply by 1. See, times by 1, times by 1, but you don't have to do it, because whenever you multiply anything by 1, it's not going to change it. Because how do you get 3x minus 5 from 3x minus 5? You can either multiply by 1 or just not do anything. you don't have to do it because it's already, the denominator is already equal. It's already the same as the LCD. So we're going to multiply out. The bottom will be the same, 3x minus 5. This times 1 will be the self. The top, we distribute -3. Negative 9x plus 15. Negative times negative will be positive. And minus 5. So this minus goes with in front of the top. And reduce, combine like terms further. Negative 9x plus 11. And look, there's nothing to factor out. No GCF, no GCF. So that should be the simplest form. All right, questions? Okay, so that is all examples for addition. Now, the process is exactly the same as how you add fractions, but you have to know how to determine the LCD. And when you multiply with the polynomials, binomials, you make sure you distribute it correctly and combine like terms. Okay? All right. No questions? We're going to talk about the next section, which is division. Let me kind of go back a little bit. So on Tuesday, I did give you an example of division. Let's see, where is it? Like this one right here. Okay. So in this example, how do we divide rational expressions? Keep, change, flip. Well, you can say multiply by reciprocal. And then you just kind of like break them down and simplify it, find the common factors to cross out. And the other one we talked about last Thursday was this case. So that can also be considered as division. So we'll take a closer look at this. Now this line right here means division. So what I did, how did I divide this top by this bottom? I'll still use the factoring. I factored the top, I factored the bottom, and found out they have a common factor 5x minus 4 and the x in common, cross them out. So we end up with this, which cannot be divided any further, simplify any further. So what if I want you to divide this further? To sort of like find out, just like for numbers, we did similar questions. So if I add, after you did this, you may give me an answer as 9 over 5. It is acceptable. 9/5 is the answer. But if I want you to change it to a mixed number, instead of leaving this as this form, what you can do is you take 9 divided by 5 to do long division. 5 goes into 9 only one time. And so you will end up with 1 and 4/5, right? So your quotient will be 1. 5 goes in, because 5 goes into 9 once. So one time you have 1 5 there, and you will have a leftover 4. So 4, that because 5 doesn't go into 4 anymore, as 4 over 5. All right. So when you divide 9 by 5, you can get a quotient. 1 is the quotient. Oops, quotient. And plus the 4 over 5. This 4 is the remainder. But the plus sign, usually we omit it. We automatically, when you have 1 and 4/5, this means there's a plus sign there. But the plus sign is omitted. 5 is the denominator, or you can call it a divisor. So technically, you could do this, but usually in algebra class, high-level algebra, we don't need you to do that. You can stop there. But if somebody asks you to change it to mixed number, you have to do long division to do that, right? So the same thing. What if I want you to divide this further to give me sort of similar answer? This equals what quotient plus what remainder divided by that divisor. I want you to write it in this format. And if anybody here is going to take a calculus class, and you will, technically it's calculus 2, you will need to use this. And also the idea of long division, the process is exactly the same as this, but of course much more complicated. So how do we divide variables by variables in the long division? Okay, so the long division process. Here I give you an easy example, right? But I'm gonna give you another one. All right. Okay, so let's go back to our province. This is gonna be section, is that 4.7? I think it's called. Okay, this is 4.5. We're dividing polynomials. Again, previously, we did talk about dividing polynomials. We used the factoring, but here we're going to be using long division, because when you do factoring, you have to stop at a certain step, like right here. Okay, so you have to stop here because you cannot factor the top anymore. You cannot factor the bottom anymore. You cannot really do anything else. But sometimes in certain occasions, we may want you to find out what the quotient is and what the remainder is. And you can still, just similar to the process of changing an improper fraction to a mixed number. And you can find the quotient and the remainder. Okay, so that's what we're going to talk about in this section. Okay. So let's look at the long division process. Okay. So in DO5, if you took it with me, you should have learned that already. Maybe DO4. Okay. So first, I'm going to ask you to compare, to refresh your memories about long division. Suppose I want you to divide. Let's try to do 497 by 20, maybe 23. Okay. And we want you to find out the quotient. The other way to write it is you can write it as in the fractional form. So 497 divided by 23 to change it to mixed fraction. So what it would be the quotient? Mix the number, what it will be the remainder divided by 23. So that's what we're asking for. We're going to do long division, 497 divided by 23. Okay, so again, the first number, if anybody here does not remember long division or has never learned long division, please pay attention here. We did talk about this in DO5 class. So the first number goes under the line. Okay, the divisor, the second number, or the bottom number goes on the front. Okay, can someone tell me what we're gonna do here after we set it up? What do you do? Check first.
You see if 3 goes into 4 and it doesn't, so 23 goes into 49.
Yes, very good. Thank you, Stephanie. Okay. All right. So exactly like what Stephanie said, you first check 23, does it go into 4? No. You can put a 0 up there, but you don't have to, because a 0 at the beginning of a number, if you have a bunch of zeros, it just means 723. These zeros don't do anything, right? But if you have a bunch of zeros after the number, they do change the number, but in front of it, so that doesn't really do anything. You can put a 0 there if you want, or not, just omit it. Then, like Stephanie said, you're going to check how many times 23 does go into 49. You add another digit, so 49. 23 does go into 49 because 49 is bigger. And now you need to ask yourself, 23 goes into 49 how many times? Can you all see that? How many times? If you can't, there is a quick way to check. You can just forget about the second digit temporarily. It's like 20 goes into 40 how many times? Or 2 goes into 4 how many times? That's much easier to do, right? Because 23, 49, it's with the 3 and 9, 2 digits, not very easy to see. So you can kind of like doing 20, 40, but 20, 40, you can, it's like when you ask yourself 20 goes into 40 how many times, it's similar to 2 goes into 4 how many times. So technically you only focus on the first digit to see 2 goes into 4 2 times, right? I'm going to put the numbers back. Okay, so this just kind of help you how to get a number to start with. Okay, so I found out 2 goes into 4 2 times. By the way, I think because if I ask you how many times 2 goes into 4, everybody knows, right? If you, how did you figure out it's 2? But if say anybody who doesn't know how many times, who cannot tell 2 goes into 4 2 times, what you could do is you can take 4 and divide by 2. 4 divided by 2 gives you a 2. That's exactly how many times. Exactly like if I ask you, how about if I ask you, let's say 7 goes into 14, how many times? You can take 14 divided by 7, and that gives you 2. So whenever you try to figure out 7 goes into 14 how many times, it's like doing division. Okay, 14 divided by 7. So the same thing here. So you're going to use division to figure out your quotient. 4 divided by 2. And technically it is division, right? Because this line means division here. So you do 4 divided by 2. 4 divided by 2. That's the long division symbol. But if you put it vertically or just use this traditional symbol, 4 divided by 2 is 2. So you get a quotient. And next, after you figure out the quotient is 2, 23 goes into 49 2 times. For numbers, you might have to fix this number later. Maybe 2 is too big. Maybe 2 is too small. It is possible. You may have to increase it to 3 or reduce it down to 1. It's possible. But first, you got to check, well, what's the next step? After you figure out 23 goes into 49 2 times, what's the next step you're going to do here? Maybe... Oh, Stephanie, continue.
You would subtract 46 from 49.
Wait, 46, where did you get 46 from?
Because 23 goes into 49 twice.
Yeah, but where does 46 come from? That's the step I want you to actually say it, specifically say it. You had a number 46, but how did you get 46? What did you do?
I took 23 and added it twice, which makes 46.
Oh, okay, you did addition. That's fine. But you can also do what? Multiplication, right? It's like 23
right.
times 2. Yes, so you're going to take 23 times 2. That gives you 46. So you're going to multiply 2 with both digits here. So 2 times 3 is 6. 2 times 2 is 4. And Stephanie already actually told us the third step, which is subtraction. So you're going to subtract 49 and minus 46. So I'm just going to write down the subtraction here. So you can see step 1, we did a division, divide. Step 2, we did a multiplication, multiply. And step 3, we did a subtraction. So in long division, a lot of operations are involved. That's why long division is sort of difficult to do, because you have to remember all these 3 steps. First, you got to do division to figure out a quotient. Some students may not need to do division. Say, I can see 2 goes into 23 goes into 49 2 times. But if you have trouble, you do division. After that, second step, it's actually multiplication. You take 23 multiplied by 2. That gives you 46. After that, you do subtraction. So 9 minus 6 is 3. 4 minus 4 is 0. You don't have to put a 0 there. Okay, so that's just finished the first round of the long division process. And if you have any more digits, you got to bring it down and try the process one more time. Okay, so we're going to do the same thing. 23, repeat these 3 steps again. 23 goes into 37 how many times? Well, you can check 2 goes into 3 how many times, at most 1 time, right? So we're going to put a 1 there. And step 2, multiply. So you take 1 multiplied by 23, you get 23, and they do subtraction again. So that gives you the remainder 14, because 23 doesn't go into 14 anymore, and we don't have any more digits left. So let's write down the answer. The quotient will be 21. So it's going to be equal to 21 plus the remainder is 14 over 23. Okay. All right. Any questions about long division process here? Okay, so I want you to remember these 3 steps, and you may need to do these 3 steps a few times, but depending on, so if I have one more digit here, if I have like another 8, you got to bring it down to do it again. So but every single time you just repeat these 3 steps, divide it to figure out the quotient, and multiply the quotient with that number on the front, and subtract. The subtraction, usually we don't have to put a minus sign there. We just remember it's subtraction. Nobody's going to do addition here, right? But we remember it's subtraction. But I'm going to put a minus sign there because for polynomials, you may forget, because with a lot of minus sign in there, you may forget to do subtraction. So let's look at this example right here. I'm going to bring over that process, put it over what we just did, and move it here so you can refer to that process. So what we just did is 497 divided by 23. So first step, step 1. Okay, step 1, you divide to find the quotient. Divide to find the quotient. Okay, so we divided 40 by 4 by 2 to get 2. And step 2, we multiply the quotient. The quotient and this divisor here, the number in the front, and divisor. So we do 2 times 3, 2 times 4, 46. And the final step is to subtract. Subtract the numbers you line up with and to get 3. And then you bring down whatever you have and repeat the process again, divide. And so that's how we get the answer, right? So here I'm going to repeat this 3 process steps to divide these. Okay, so first step of long division. Remember the top goes under the line. Copy it. The bottom goes on the front, x minus 2. Okay, so now step 1. We need to figure out. So remember here, we try to, like Stephanie said, you're going to try to figure out 23 goes into 49 how many times? Apparently 23 doesn't go into 4, right? So 23 goes into 49 how many times? So here, in our case, x minus 2, those 2 terms corresponded to 2 digits here. And so we're going to have 2 terms here to match with 49. So we're going to try to figure out x minus 2 goes into 3x squared minus x how many times? That's much harder to do, right? Like I said, and everybody probably can see 23 goes into 49 2 times after maybe just by looking at it. Well, but it's going to be hard to see x minus 2 goes into 3x squared minus x how many times. But the process I just said will still work. You're going to use division to find out quotient how many times. So what division are we going to do? Remember that tip that I gave you? So you can kind of ignore the second digits, 3 and 9, because just like 20 goes into 40 how many times? As you want to match the first number. If your first number is bigger, if you put 3 here, you're going to 2 times 3 get 6. It's not going to work, right? So you want to match this or at least or smaller than that. So that's why only the first, when you try to determine how many times goes in there, only the first digits matter. Okay, so the same thing here. If you try to figure out x minus 2 goes into 3x squared minus x how many times, the second terms don't really matter. You want to match the first one. If you get something too big, like 4x squared, it's not going to work. And if it's too small, you want to increase it, right? So the same thing. We just need to look at x and the 3x squared to figure out how many times. And how do you determine that? Do division. So like I said before, if I ask you 7 goes into 15 how many times? It's like 14 divided by 7. So you just do 14 divided by 7, which is 2. The same thing here. X goes into 3x squared how many times? You have x on the front, corresponds to 7. 3x squared under the line corresponds to 14. How do you figure out how many times? Do the same thing. Take 3x squared divided by x. Right? Can everybody see that? So this is an important process here that will get you started. So in order to figure out what quotient goes in up there, well, how many times x goes into 3x squared, I'm going to do division. So step 1, I'm going to take 3x squared divided by x. And we learned this before the first exam. And we do 3 divided by 1 here. It's not a number, which is 1. X squared divided by x is x. So it's sort of like doing 14 divided by 7 gives you 2. So that goes on the top. Okay, so if you don't know where to put 3x, it goes up, top here. Okay, usually you line it up with the second term. After we found out x goes into 3x squared, 3x times, what is the second step? Remember what we did. So the process imitates long division. So whatever you do here, you're going to do the same thing here. So remember what we did here in the second step? Can you follow this? Imitate this? See, tell me what we should do here. Anybody besides Stephanie? Jordan, can you tell us? Are you there, Jordan? No? Jackson, are you there?
Yeah, I'm here.
Okay, so do you know what to do next? In this case?
What am I looking for?
We're trying to finish the long division process here. So we're right now we finished the first step, divide to find the quotient. I already figured out x goes into 3x squared 3x times. So now we're on the second step. Multiply the quotient and the divisor. So in this case, what do I multiply?
I have no.
Does anybody have any idea?
Multiply 3x by x.
Close, Garrett. The divisor has actually 2 terms, right? X and minus 2, right? Okay, so go back to long division process. After we figure out 23 goes into 49 2 times, what did we multiply? We multiplied the 2 with what? 23, right? Do you see that? Okay, go back. Okay. Although we only used 2, the first digits, 2 and 4, to figure out the quotient, 2 goes into 4 2 times. We put 2 there. When we multiply, we need to multiply 23, the whole number. That's the divisor, by 2 to get the number, right? 2 times 3 and 2 times 4. Think about the long division process. So here, Garrett, can you correct the answer? So you said multiply 3x with x. What we should actually multiply?
3x times x minus 2.
Yes, that's right. That's correct. Good. Can everybody else follow this? And this process, again, like I said, even with numbers, the long division is sort of complicated. You have to do those 3 steps. With the variables, it's going to be even more complicated. And especially if you're not familiar with the long division process, you might get lost. But if you remember the long division process with numbers, the process here is repeating that. So you might refer back to the process you're doing with numbers. Okay, so I would take the second step. I'll take 3x and multiply with the divisor, which is x minus 2 there. This process is imitating 2 times 23, gives us 46 down there to line up with 49, so we can do subtraction. So let me first multiply. Okay, 3x times x. We learned this before the first exams. 3x times -2, so -6x. So that's what we got. Okay, and we're going to put this line up with the first two terms we have. Okay, any question about this? Does everybody have any questions about why we're doing this? Okay, so 3x times x minus 2. If you can do everything in your mind, you don't have to write them down on your paper. But if you have trouble, it's better to write it down so you can see. So for example, the first step, you're doing division. You take 3x squared divided by x to get 3x to put it up there. If you can do this in your mind, 3x squared to do this in your mind, you don't have to write it down. Similarly, when you multiply 3x with x minus 2, if you don't, you can do that in your mind. You can just write down the answer here. You don't have to show me this. Okay, now we're done with the first step, division. Second step, multiplication. The final step is to do subtraction. We subtract them. Now, we also learned in the first exam, we did those questions. So we talked about how to combine like terms. Be very careful here because we have a bunch of minuses. Can someone tell me what is 3x squared minus x? Minus 3x squared minus 6x. You can work this out on your scratch paper and tell me what your answer is. But you do have to be very careful. You do need to be careful with the minus signs. So I'm going to go ahead and put a minus sign here. So you're doing this minus that, okay? Okay, if you got the answer, type it in the chat box. I can see how many of you got it. We're doing 3x squared minus x minus 3x squared minus 6x. This process is imitating 49 minus 46, okay? You can do negative x minus negative 6x, 3x squared minus 3x squared. What do we get? Okay, so Garrett put negative 7x. Jackson put negative 7x. Okay, that there is a mistake in there. Any different answer here? 5x. Natalie put a 5x there. Okay, so which one is correct? Any other tries?
I think it's 5x too.
Okay, Stephanie, right? Yes, actually the correct answer should be 5x. So that's why I was mentioned before, with the variables, with the polynomials, you gotta be very careful. Why? Because you have many minus signs already. With the numbers, when you do, let me kind of clear here a little bit so you can see better. So when we did 49 minus 46, normally nobody's gonna put a minus sign there, like minus between them, because we remember it, and you don't have any minus sign in the numbers. So 9 minus 6 is 3, 4 minus 4 is 0, right? So nobody's gonna make a mistake. But with the variables, see, there's another minus in here. You may have negative numbers. Okay, this never happens with numbers, but it could happen with the polynomials. So you actually doing what? It's negative x. This minus also applies to that, remember, right? So technically you have another minus sign here. It's like a 9 minus 6, 4 minus 4, right? So I'm going to put a minus sign here to remind you. It's like a negative minus negative 6. So you're put a 1 there. So it's like doing negative 1. The third step is doing 3x squared minus x minus 3x squared minus 6x. Okay, I did notice on the first exam, or if you have your practice exam with you, on page 3, the first two problems, I did notice many students took the exam, still made mistakes. So there's a minus sign in front of the parentheses, which means you got to distribute a minus to both of them. So it's like 3x squared minus 3x squared. 3x squared minus 3x squared, they will cancel because 3 minus 3 is 0. 0x squared is 0. That part is correct. But when you do subtraction, it's -1 minus -6. So it's like this -1, negative x, minus another -6. Well, negative will become a positive. So it's like doing -x plus 6x, which gives you a 5x. Okay, so that is the tricky part right there. Okay, so usually I recommend you do subtraction here, go ahead and change the signs so you won't forget to do that later. I mean, with the numbers, you don't have to worry about it because you never get a negative number in long division. But you possibly could. You definitely will with polynomials. So let me write this again here to show you what I would do. Okay, so this is what I'm going to do. When I realize the final step we're supposed to do subtraction, I am going to cross these out because it's minus, right? You can put a minus sign there. 3x minus 3x squared, they cancel out. And right here, you're doing -x minus negative. So negative becomes a positive. So you can immediately change this to a plus sign because -1 minus -6, keep change. So you will change it to plus 6. So that gives us a 5x. So I would go ahead and change the sign so you won't forget to do that later. Now we finished the first round of those 3 steps. Okay, any question about this? So that part is a very common mistake. A lot of students would mess that up because they forget there's another minus sign there. And in the number already there's a minus. Okay, so next part is to repeat this whole process again, moving down the -5 and repeat it. Okay. And Stephanie got it, and Garrett, I don't know if anybody else understood the process here. Maybe try Garrett again. Garrett, can you tell us what we need to do here? The next, after I bring down -5, what should I do next? Are you there? Did I lose him? Oh.
We're gonna see x going into 5x.
How many times?
The x's are gonna cancel, so you're gonna be left with 5.
You'll be left with 5. Yes. Good. Thanks. Okay, so this is what you need to do. If anybody still doesn't know what to do here, you do step 1, divide. Divide what? I didn't put it here, but divide the first terms, usually the highest, the terms with the highest degree, the highest power. So you divide 5x by x to figure out what you're going to put in the quotient. So you're going to take 5x, divide by x, 5x, divide by x. The first term divided by the first term. And like Gary said, you cross out x, you're just going to be left with a 5. So I'm going to put that +5. By the way, you're going to need to put a +5 there. If you don't put +5, it's like multiplication. 5 means positive 5. So put a plus sign there. So now, the second step, Jackson, do you know what to do now after we figure out the quotient 5?
Yeah.
What do we do next? Can you tell us?
You just multiply the 5 by the x minus 2.
Yes, very good. Thank you. Okay. So hopefully everybody is still following. I'll give you more examples, but if you have any question, feel free to stop me. Okay, so you would take, after we figure out the quotient, you do the second step, you will multiply the 5 with x minus 2. Similar to the process here, 1 times 23 gives you 23, right? So we're gonna do the second step. Again, if you can do this in your mind, you don't have to write it down. I'm going to here x minus 2. So you do 5 times x, 5 times negative 2. That gives you 5x minus 10. Okay, and you will line this up with what you have. Just like you line up 23 with 37, so you can do subtraction. Okay, now I'm also going to ask everybody here to write down the final answer here, because we are done with the other terms we have. We don't have any more. So remember, you're still doing subtraction here. There's a minus here, minus there. Okay, so type in the chat box what you are going to get after you subtract. So the final step, 5x minus 5 minus 5x minus 10. Type your answer in the chat box. Subtract, subtract. Okay, yes, Jackson, put a 5 there. Natalie, put a 5 there. Aiden, put a 5 there, good. All right, okay, Garrett put 5 there, very good. Okay, yes, Jake, that's all correct. The correct answer is 5. Okay, so you can go ahead and put, change the signs if you want. So keep, change, change. Okay, so this time looks like we got more correct answers this time. Okay, so it's -5 plus 10, that gives you a 5. All right, so we are done with the division process. Now let's write down the answer. Let me see if I can just go ahead and put the answer up there. Here a little bit. So similar to the problem we just did, when you write down answers of 497, when you divide 497 by 23, when you write it as a mixed number, that would be 21 and means plus. I'm going to put a plus sign here because that's why for variables, we cannot omit the plus sign. For numbers, you can omit a plus sign. So the remainder goes on the top, 14 goes on the top, and 23 stays. So for numbers, you could just omit that plus sign there and put a 21 and 14 over 23. This is okay. But for variables, you cannot omit the plus sign. So when you write it, okay, what's the quotient? This is our quotient. It corresponds to 21 there. 3x and the denominator will still be the same as what they gave you before, x minus 2. Again, this plus sign cannot be omitted. If you omit it, it just looks weird. We may think it's multiplication. For numbers, we don't think it's as multiplication. We think it's a mixed number, but for variables, you might think it's multiplication. So we have to put the plus sign there. Okay, questions? We finished the one example here. All right, so the rest of the examples are going to be exactly the same. We may have a longer polynomial in the numerator, and but we're still going to repeat these 3 steps: divide to find the quotient, multiply, and subtract. So it's always repeating these 3 steps. Okay. I know some of the students may have learned in high school, there's a method called synthetic. I'm just gonna put it here. So there is another way called synthetic division. If you heard of this name before, learned it before, you can use synthetic division to do this one. Okay. But not every long division problem can be done by synthetic division, because synthetic division has a restriction. You can only divide something by x minus something. So it has to be, the number in front of x cannot be anything else other than 1. So it has to be x. if I put a 3x here, you cannot use synthetic division. You have to do the process I just showed you. It will still work. So synthetic division only works on problems like this, x minus something. So the first example that I just gave you, you can use synthetic division because the number in front of x is 1. So it should work. But for those of you, if you have never heard of what synthetic division is, and you don't have to worry about that, you can just, because this works on any type of question. There is a bonus problem that I gave on the homework this week, and the number in front of x, like this, is not going to be 1. So for this problem, when you have a 3, not 1, you cannot do synthetic division anymore. Okay, cannot do synthetic. Synthetic division actually is a quick way to do long division without carrying down all the variables. We only put down those coefficients and numbers, but I mean, the process is kind of similar, but I'm going to skip that here, skip synthetic division here due to the time. So I'm going to keep doing this process, okay, because this is the universal way that works on any problem. So I'm going to use that to do another example. I will also give you an example on the bonus problem. So if you want to get more bonus problem, especially those students, if you did not do well on your exams, please make sure you take advantage of the bonus problems I give in class, because this will help you bring up your average a lot. And again, at the end of the semester, I won't give you any extra credit problems anymore, because throughout the semester, I have lots of chances. I give you probably a total of like 50 points that you can add to your total. So, because I do notice that not everybody, only probably half of the students are doing the bonus problems. So please make sure you don't miss those bonus points. And also, I have bonus points on the homework sheet. Okay, so let's go back to this example here. So remember those 3 processes. Pretty much divide, multiply, subtract. Okay, so let's set this up here. 5x cubed, the top goes under the line. The bottom, x minus 1. And this one, you may also use synthetic division if you learned it before, because the number in front of x is 1. Okay, so now, not sure how many students can remember the process. I know Stephanie got it, Garrett got it, Jackson got it. I don't know if anybody else want to try. So what would you do in the first step? Jake, do you know what to do in this first step? Jake, are you there? Natalie, are you there?
Yeah.
Do you know what to do here?
You would multiply it by 5x squared.
Wait, say it again. Did you say multiply?
Yeah, by 5x squared.
Oh, you multiply by 5x squared. But can you tell us how you got 5x squared? Where does this come from?
X goes in the 5x cubed.
Well, your mic has a lot of echo sound. Okay. Aiden, do you know what to do? Aiden?
On which part?
How to figure out. So Natalie said you will multiply 5x squared with x minus 1. But how did she get 5x squared? Do you know?
By dividing the x out of 5x cubed.
Yes, very good. Thank you. Okay, so if anybody is here still not sure how to figure out 5x squared, the quotient part, again, remember the first step, you would divide the highest, usually the first terms, the terms with the highest exponent. So you divide them to get the quotient. So like what Aiden just said, you take 5x cubed, take this one, divide by x. So I think most of you can do this in your mind without writing it down. 5 divided 1 is 5. X third divided by x cubed divided by x gives you x squared. Okay, so that's what you're gonna put on top of the line as your quotient. All right, now next step. What do we do in our second step? See, Raid, are you there?
Yeah, I'm here.
Okay, can you tell us what you do in the next step?
You multiply 5x squared and x minus 1.
Yes, very good. Thank you. Okay. So that's exactly what we're going to do. Multiply 5x squared times x minus 1. Again, if you can do it in your mind, go ahead and just write down your answer, line up with those two terms. But if you can't, write down your paper, distribution. We learned all of these before the first exam already. Okay, so I'm going to copy this down here, 5x cubed minus 5x squared. Sorry, I missed the square there. Okay, lining up, and now do subtraction. Okay, again, I'm going to ask you to write down your answer in the chat box. After we do subtraction, we're going to subtract this one and that one. What answer will we get? Okay. Got one answer. Oops. Okay, 3 answers. All right. What you see from Jackson, Garrett, Natalie, and Bryson is correct. X squared is the correct answer. If you got a different answer, just try to pay attention here. So what we're gonna do is we're doing subtraction. So 5. I don't know, somehow my eraser just stopped working. Okay, so we're gonna do minus here. 5x cubed and minus 5x cubed, they cancel out. But there's another minus sign here. So -4 minus -5, that gives keep change. So -4 plus 5, that gives us 1x squared, or just x squared. Okay, so the first round of addition, division, multiplication, and subtraction is done. Now we bring down plus 3x. So we repeat this whole process again. Okay, so we're going to try to figure out x minus x goes into x squared how many times? So you take x squared divided by x. So you do x squared divided by x. That gives you x. And you put it up here. Again, don't forget to put a plus sign in front of x. And that's the first step, division. Second step, we do multiplication again. So x times x minus 1. Distribute. So that gives us x squared minus x to line up with what we have. Okay. So one more time here, can you type your answer for the subtraction here? So we're going to do subtraction again. X squared plus 3x minus x squared minus x. Minus and minus. Okay. All right, so we're going to do x squared minus x squared, which is canceled out. Yes, okay. So what I saw, Jackson, Natalie, and the Charlie, so we do subtraction, keep, change. So you can go ahead and change the signs here. And 3 plus 1 will give us a 4x. Okay, now one more. The final term, bring it down, 4x minus 1, and repeat the whole process again. So if you understand the one round of division, how to figure out a quotient, how to multiply, how to subtract, the rest of them just exactly the same, just repeat. So x, we do 4x divided by x. That gives us a 4, because x cancels x. So let's just put a plus 4 up there. And then we distribute a 4 to, so we multiply 4 and x minus 1. So we get 4x minus 4. And now do subtraction again. Minus, So keep, change. So -1 plus 4, that gives you 3. So let's write down the answer up here. The quotient, 5x squared plus x plus 4, plus the remainder 3 over x minus 1. So that's the final answer. Okay. All right, questions? Now in the, well, I guess my computer just lags now. Okay, so oops, I guess I lost everything I did. So in this process, we are going to divide. We're going to repeat the same process again, but with the 3 in front of it. Let's see how much difference it makes. So copy the top, 3x cubed minus 5x squared minus 23x minus 6. Divide by 3x plus 1. Okay, so previously all the example is minus, but now it's plus. So first step will still be the same. You take 3x cubed divided by 3x. Okay, now divide them. We got 3 cancels 3. X third divided by x, we get x squared. I'm going to put the x squared up there. Okay. Now, second step, you multiply x squared with 3x plus 1. So you're going to distribute to get 3x third plus x squared. Okay. So again, now I'm probably just going to do this in your mind. If you are familiar with the process from now on, so you do x squared times 3x cubed. X squared times positive 1, that's x squared. So lining up. So as you can see, although we couldn't use synthetic division, long division process is exactly the same. So no difference at all. You just still do, you take this, divide by that. Okay. Now subtraction. And I need you to write down your answer in the chat box. You're going to do minus here and minus here. So it's -5 minus +1. So -5x squared minus +1. I can put a 1 there. +1x squared. You can type your answer in the chatting box. So it's -5x squared minus x squared. Okay, that's right. Good. Okay, so if you say I'm having trouble seeing it this vertically with a bunch of things here, write it down on your paper horizontally, because we did this a lot before the first exam, right? So you will be able to see it better. So it's -5 minus 1, -6. Okay. All right. Yeah, what Garrett and Aiden had was correct. -6x squared. Okay. So now bring down the next term, -23x. Repeat the process again. This time first time we have a minus here. So we still, the process doesn't change. We still take -6x squared divided by 3x. So you're going to get -2 times x. So let's put a -2x up there. And you do -2x times 3x plus 1. So you're going to get -6x squared minus 2x, because -2 times 3 is -6. X times x, x squared. And then you do -2 x times 1 would be -2x. Okay, subtraction again. Type your answer in the chat box. So we're going to do minus here and minus there. If you have trouble seeing vertically, write down horizontally. The first part usually always cancels. -6x squared minus -6x squared. Of course, anything minus itself, you will always get a 0. So usually the first part always cancel. First terms always cancel. And the second part, it's -23x minus -2x. Keep, change, right? So we can do keep, change. Okay. Yes, that's correct. So Garrett and Natalie put the answers there. It's negative 21x. Very good. Okay, the final step. Bring down the negative 6 and repeat. So I do negative 21 divided by 3x. That's negative 7. So I just did this in my mind because negative 21 divided by 3 is negative 7. X cancels that x. Okay, now multiplication. Negative 7 times 3x, negative 21x, and negative 7 times positive 1 is negative 7. So keep change, keep change. Oops. Okay, so you will end up with negative 6 plus 7, which is positive 1. Okay, so I'm going to write down the answer here. Quotient x squared minus 2x minus 7 plus the remainder 1 over 3x plus 1 as the final answer. Okay, questions? So I gave you 3 examples of long division. And again, if you have trouble doing these, go back to the recorded class video will be posted on Blackboard. And also I have extra videos there. And so if you want to follow the, say when you go home to do the homework, you forgot the steps and you can go back to follow these examples. So each example I gave you here is very similar to the homework problem in your worksheet. Okay, now last, there's another type of division that you got to do. It's easier than the long division. This type would be much quicker. The difference is, first take a look at the denominator. There's no plus or minus. This just means, this minus does not mean subtraction. It just means negative 4 times x cubed. 3 times x times x squared times b squared. So compared to those examples, we had to do long division because the denominator has 2 terms, x minus 2, x minus 1, or 3x plus 1. That's why we had to do long division. But in these questions, there's long division will still work, but you don't have to do long division. These will be easier. So what we need to do is, we also did this in Math 305. So think about a question like this. If I ask you to do 6a plus 4b minus 2c and ask you to divide this by 2, what would you do? 6a plus 4b minus 2c divided by 2, what would you do? Any idea? Any suggestions? Nobody? Think of this as I have 6 apples and 4 bananas minus 2 of something, and say 2 carrots, and I cut everything by half. Maybe I can use plus here. It will probably makes more sense in real life. So I have 6 apples and 4 bananas and 2 carrots. I want divide by 2 means cut everything in half, right? Yes. Bryson said take 2 out of each number. That means what? Divide each one by the bottom 2. Yes, that's kind of the same thing here. So you would take 6 apples you have, divide by 2, cut 6 apples in half, and cut 4 bananas in half, and then cut 2 carrots in half. So you divide them through. Divide each term by the bottom. And 6 divided by 2 will be 3. 8 will stay. So 6 apples divided by 2, you get 3 apples. 4 bananas divided by 2, you get 2 bananas. And 2 carrots divided by 2, you're going to get 1. 2 divided by 2 is 1, right? 1 carrot. So the answer would be 3a plus 2b plus c. All right. So this idea can be applied here the same way, except we have more variables. So when we do this, treat the bottom as just the number 2. So you're going to take each top, take this, divide by the bottom, and take that, divide by the bottom. The same thing here. You take the first, divide by the bottom, the second, divide by the bottom, and the third, divide by the bottom. Divide all the way, each one by, or kind of like Bryson said, deal with each one, right? You said each number here, we may have variables. So you will just take each one divided by 2, okay? So we have, this step can be omitted later when you do the homework. If you see I can do this in my mind, you don't have to show me, okay? Minus 32x fifth divided by negative 4x third. So what I did is I take the first term, negative 28x6, sort of corresponding to 6 apples. So whatever that is, divide by the whole bottom. And minus, this minus sign, I copied it. And do 32x fifth divided by negative 4x cubed. Okay. And again, this step you may skip it. You may do this in your mind if you can. So negative 28 divided by negative 7. Each problem is something we learned before the first exam. So we did this, and we had similar questions on the first exam. I didn't notice some students were a little confused about the formulas. I think for division it might be okay. The confused one will still be the, when do we multiply exponents? When do we add exponents? But for division, we should all know it's subtraction. Subtract the exponents. Okay. All right. Can someone maybe tell me what the answer is for that part there? Let's try. Okay, is Charlie, are you there? Is Charlie still there? Allie, are you there? Allie Madison? No? Okay. How about Ryan? Where's everybody? Colin? Colin, are you there?
Yeah, I'm here, but I don't know.
You don't know how to do this one?
Yeah, I don't know.
Let me ask you then. When you do division, so this is something we did on the first exam. So you will just divide them separately. What is negative 28 divided by negative 4?
6.
Wait, 6? 4 goes into 28. How many times?
Oh, 7.
7.
Yeah, my
Okay.
bad.
Okay, and then what about x6 divided by x third?
That's 3.
Say the base also. That would be x to the third. Okay, x, you will keep the base x. You subtract the 3 from 6. So the answer should be 7x cubed for that part. Okay, can you also do the next part then?
That's.
You can,
8.
yes, okay. You can associate this minus sign with 32. So negative 32 divided by negative 4, it's 8. What about x fifth divided by x third?
X to the second.
Yes, very good. That's it. Thank you. Okay, so what Colin just said is exactly correct. So the answer, you simplify that. That part we did it before the first exam. The formula, subtract exponents, divide number by number. So you get x7x cubed plus 8x squared. But these two are not like terms, so you won't be able to combine any further. Okay, so similarly, we can do the second one. So the process, the first step, again, can be omitted. Negative 12a fourth b third divided by 3a squared b squared minus 18a fifth b squared divided by 3a squared b squared and plus 48a squared. I can't even see what that one is. Okay, b6 divided by 3a squared b squared. Okay, so let's divide them through. Bryson, can you do this one? Are you there?
Yeah.
Okay. So negative 12 divided by 3. That's a
Negative 4 a to the second.
yeah. What about b third divided by b squared?
B to the first.
Yes. Okay. Continue the next part.
This is,
18 divided by
yeah,
3.
6 a to the third.
These will cancel out, right? B squared, B squared.
Yeah.
Okay, continue. Well, this probably, I don't know. Can you see that? 48 divided by 3? Are you able to
Yeah.
see what? Yeah, what is it? You can use your calculator.
Is it 16?
Yes, it is. Now a squared
B to
divided
the
by a
fourth.
b to the fourth. Yes, thank you. Okay, great. So that will be the final answer. Again, there are no like terms that you can combine. So this type of division is easier when the divisor or denominator only is a monomial. Denominator is monomial because which means there's only one term here, no plus or minus. So it's much easier than when you have a binomial in the denominator. You got to do long division, which takes much longer time. Okay. All right. Questions? That's all we have for today. Okay, so I'm gonna do. If you don't have any questions, let me write on the bonus down for today. So again, you have until tomorrow. This number 12. 2:30 to finish these. Okay. So first we're gonna do. I guess I can do one addition of the fractions. So let's try to do 3a squared minus a plus 1 over 5a. Okay, the first one. The second one, we try to do one with long division then. So okay, so now you can type down present for today's class. Oh, I have to, okay. All right, so I'm gonna make a spot for bonus today. I don't have it there yet under week 7. You can stay if you have questions. Otherwise, you can leave the meeting and submit your work to Blackboard.